Hey there, I am going to go over the lab report that you need to do for lesson 1.04. I'm going to scroll down here. It is the lab for the law of conservation of energy. Now, when you get here, you're going to notice that there are two documents or two icons with the open page. The first one is the lesson page with all of the lesson materials you need. The second one is the Google Doc format for the lab report. You do not need to use the Google Doc format if you don't want to. The actual lab report is also located on the last page of the lesson. So it's your choice if you want to use it from Buzz or if you want to use the document from Google Docs that I've provided to you. Some of you may not have access to the Google Docs because your districts have very strong filters up that won't allow you to access WVS shared things. And if that happens to you, know that we are working on that and trying to get that corrected. All right, so when I open the lesson pages, I'm going to jump to the last page, but you're going to carefully work through all 4 pages, making sure you understand the scientific process, the scientific method for doing experiments. And when you work your way to page 4, you're going to see the questions at the top for you to review to make sure you understand and are ready for the assessment and the activity. And then the assignment is in the green box on the last page, as always, for our science class. Now here is a link for the Law of Conservation of Energy Lab. These are the directions, and this is where the simulation tool is. So if you are confused on where to find this simulation tool, you're going to have to click this link and open it up. Right here is a copy of the lab report that you can use to complete the work. I shouldn't have done that because now I'm going to have to go back and it's going to take me a while, but I wanted to just you to see what it looked like. You can open this up and print and type on it and turn it in, or you could print it off and handwrite that. One of the things I don't like about Buzz is that the back button really doesn't take you back to the last page. It takes you back to the previous lesson, which I think is annoying. Anyway, all right, so here are the directions and the simulation. I'm going to go ahead and open this. So here it tells you the introduction. You're going to be doing work in a skate park. You're going to be looking at energy in a skate park. We're going to use a simulation to explore that law of conservation of energy, where energy cannot be created or destroyed, but merely transferred or changed from one form to another. Over here, you're going to see a link for the Skatepark Basics. You're going to want to open that up because it's going to give you directions for how to use the simulator. All right, so if you get confused like I do, how do I take a screenshot using this thing? This will tell you that you're going to go to the pancake menu in the bottom right-hand corner to be able to access that screenshot tool that they have. And it tells you all of the other things that are included in both the intro screen and then the playground screen where you're going to create your own ramp, which is kind of cool. Okay, so I like to leave that open as I am working. It just sits up there in the top. And here it describes, you're going to have part 1. You're going to do some research in the intro section, the intro simulation. Your objective in part 1 is to explore the relationship between potential energy, kinetic energy, total energy, and speed. You're going to look at all of those features in the simulation, and you're going to write your observations in the lab report. After that, you're going to move on to part 2, where you are going to design and test your own skate park ramp, which I did it. It's a lot of fun. You're going to do that. Your ramp must include these 3 things. It must have at least 1 loop. It must rest on the ground, and the skater must be able to complete that ramp without falling off. And when they do fall off, it's kind of fun to create it and see what happens. They do fall off until you get it set up right. Okay, so here is the actual simulation, and you can see it forces us to start in that intro box. So I'm going to go ahead and open it up, and I'm going to turn on the pie graph, the bar graph, the grid, and the speed. The grid is telling me height in meters, so I can take my skater up to 6 meters, drop him on this ramp, and watch what happens to my energy. Notice what's happening to the kinetic energy, the potential energy, the thermal energy, and the total energy. And here is my speed gauge. All right, then I can take him off and I could start him at 4 meters and see what happens. Okay, that's what the lab is going to ask you to do. It's going to ask you to start the skater at different heights and observe what's happening to all of these different things. If you need to change the mass, you can increase the mass and you can decrease the mass. You can also look at different types of ramps. He just disappears. I love that one. And play around with what you notice with those. All right, once you finish with that, I have to figure out how to get back home. Oh, here's the home button. We should be able to move on and play around with friction, where we again have the same loop with the same data, and I can now put my skater on those different heights, and I can either decrease the amount of friction so there's none, or I can increase the amount of friction and give lots of friction. Remember, friction is that force that acts against motion when two objects are rubbing together. When two objects are rubbing together. Easy for me to say. I'm going to get a lot of laughing emojis on that part of the video, I'm sure. All right, so I'm going to go back home, and then I'm going to go into the playground. This is where you're going to create your own ramp, and you do that by basically just dragging these guys around. You can move all the parts of it. I am not going to create a loop. I'm not going to follow the directions because I just want to show you. Interesting. Say I want to get rid of this. I can just click on it, left click, and do that. All right, so again, I can get all my graphs showing up here, because one of the requirements is that you have a height of 10 meters. I do not. So you're going to want to make sure you follow those directions. You can play around with the different tools here. Whoops, I dropped my skater. And put him on and see what happens. Let me see what happens if I do this. Oh, he fell off. See, that one doesn't work. Now, once you get it working, you're going to want to take a screenshot, and you do that by clicking the pancake and clicking screenshot. It will then download that screen onto your computer, and you can then upload it into the lab report. So I'm going to go into the lab report and get you looking at that. I'm going to go into the one that is a Google Doc where it forces you to make a copy, just because that's my preference, which is why I make them for you. I am a Google Doc fan. All right, hopefully you'll come over here with me and you'll see me on camera in a minute. There we go. All right, make sure you complete every section of the lab report. You're going to need to include your name, the instructor's name, I'm Mrs. Lohoff, the date you completed, and the name of the lab. It's called the Law of Conservation Energy. The objective, why are we exploring this law of conservation of energy? I'm sorry, the objective is, the purpose, they're telling you, I'm sorry, this is going to come later that you're going to have to say why. I'm sorry, that must have been for a different lab report that I was doing. The objective of this is to explore the law of conservation and apply that to your own design principles for your skate park. Okay, so in that first section, you need to be in the intro simulation. You're going to see these things on your screen. You're going to position the skater at 6 meters. Look what happens to the amount of potential energy, the amount of kinetic energy, the speed, and the total energy, and compare it to what happens at 4 meters. For test number 2, you're going to put your guy at 4 meters, look at what happens, compare it to what your skater does at 2 meters for potential energy, kinetic energy, speed, and total energy. Follow the directions for 3 and 4, and then answer these questions at the bottom. What is the relationship between potential energy, kinetic energy, and speed as that skater moves down and up the U-shaped ramp? And what happens to the total energy? That is part one. For part two, you're going to go into the design playground simulation. You're going to open up those tools again. You're going to complete this hypothesis. If my skater begins at a height of blank meters, you're going to fill in the blank with a height of between 0 and 10 because that's what the simulator allows you. The skater will have enough total energy to successfully complete the ramp from start to finish. Be sure to do this hypothesis before you build yours. That's what it is. A hypothesis is done before you get your results. It's what you're thinking will happen. You can't be wrong in making a hypothesis, in this case, unless you give me a number that's not between 0 and 10. That's the only way you can get that wrong. All right, so you're going to design, making sure you include these 3 tasks. Get your ramp working well with no friction. Then you're going to increase the friction and explore what happens. All of your observations are going to be put into the table right here. So I want to make sure you understand you're going to have one ramp that includes a loop, one ramp that includes that touches the ground, so make sure when you create these ramps, you're going to make 3 different ramps. All right, and I'm going to need pictures of all 3. So the design, that little snapshot that you take is going to go in here into box 1. You can insert the image that you took for the screenshot. Image number 2 should be a different ramp. And image number 3 is a third different ramp. All the ramps must have these features. Then what happens when you increase the friction, and what are your overall observations about the performance? Okay, then you're going to pick one of those 3 ramps to test further. So whatever ramp you pick, you're going to put that number here, and then you're going to put your skater at different heights. You're going to measure the highest level of potential energy. Where are they on that ramp in meters? What height are they at when it's the highest potential energy? Where are they in meters when they have the highest amount of kinetic energy? And was the run successful or not? Then you're going to pick a different height to start and record those same observations, and a third different height to start. Finally, you're going to answer the conclusion questions below. What was the lowest starting height when the skater could successfully complete the ramp? Use the data from your testing section. That's this section right here where you picked one ramp to test further. Second question, explain why a skater must be at a specific height at the start to successfully reach the end of the ramp. Be sure to use the words potential energy and kinetic energy in your answer. And finally, does your skate park playground ramp design support the law of conservation of energy? Use evidence to explain why or why not. Make sure you include both parts of that law. That is a lot, which is why you have an entire week to work on this. Take your time. If you have questions, you can go back and watch this video some more, or feel free to email me and I will help you out. Good luck, guys. I can't wait to see your projects.